So welcome to this next lesson, and today we're going to be looking at how to read from an analog pin. We're going to be looking at the differences between an analog and a digital pin. We're going to be looking at the dangers involved with analog pins, because there are some dangers. Then we're going to use analogRead to read some values, and then finally we're going to convert those into some voltages. Now the first thing is, where are the analog pins? So if I swap screens to my diagram of an Uno, you can see the analog pins are these 6 pins down at the bottom here. They're on the opposite side to the digital pins, and they are labelled A0 to A5. So 6 pins. If you've got a nano, I think you've got 8 pins, and Arduino C has 12, I think, and the Mega has 16. So there are a different number of analog pins depending on the type of Arduino you're using. Now the difference between these analog pins here and the digital pins on the other side is that the digital pins, if you can remember, if you did the lesson on digital read, you'll have found that they're sort of on or off, high or low. An analog pin is very different. It has a number of steps, 1024 steps, and those steps go from, for an Uno, if we were measuring 5 volts, it'll be 0 is no volts, and 5 volts will be 1023. Obviously we don't get 1024 because 0 is a step. So what the Arduino does is break the voltage down into individual steps. So what we're going to do now is look at a sketch on how to use the analogRead. But first of all, a warning. These pins read voltages, but that does not mean that you can just plug any voltage in. On an Arduino Uno, the maximum voltage for this board is 5 volts. It's a 5-volt board, the same with the Mega and the Nano. If you're using an Arduino C, then it's a 3.3 volt board. If you use more than the board limit, it's going to end in tears. So although you can measure voltages, if you think you're going to start measuring 12 volts through these pins, then it's all going to end in a lot of smoke. You have been warned. So let's get on to the IDE and do some programming. So here's the sketch that I've prepared earlier. Very simple sketch. If you're stuck on any bits, I've actually put the previous lessons in case you're stuck on what is an integer or how we're using the serial. We've done it all before. So we're declaring an integer, read pin. I've got a constant integer. That's an integer that's value will never change. We don't want it to be changed, and that's the pin that we're going to be using, which is analog pin 5. And it's quite a strange system. Even though it's A5, you just put it in and somehow it sorts it out internally and it knows what number pin it is going to use. I've then started the serial monitor, and then we've got the main sketch. Now in the sketch, all that it does is we get a value for read pin by using the function analogRead. So we read the value of the analog pin, and then all I'm doing is printing out that value. Now if we go over to the serial monitor, you will see that I have a whole load of numbers going up there, and it's rubbish, absolute rubbish. The numbers are all over the place. And this is an issue at the moment because I've got nothing attached to my Uno. So it's just sat there, and the pin, because it's not got any voltage or even no volts attached to it, is just bouncing all over the place. So that is a pin that's basically in free fall, and you're not going to get any useful information out of it whatsoever. Now what I'm going to do is switch to a couple of images of some circuits that you can try, and then we'll see what happens when you use those circuits. So this is the first circuit. This is the luxury circuit. Again, circuit diagram is on the Digital Town website. There'll be a link below the video to give you that information, but let's just have a quick look at the circuit. All it is to one side of a potentiometer. I used a 1K, but you could use a 10K or a 5K. They both seem to work fine. 1K seems to give a finer adjustment though for this particular experiment. So I've got to one end, one pin, I've got the ground connected, I've got 5 volts to the other side, and then the wiper, the center pin, is connected to analog 5. Now if you're on the budget tour and you haven't got a potentiometer, we'll look at an alternative now. So this is the budget circuit. Basically you take a piece of wire and you connect A5 to 5 volts. Then what you can do is move it into the 3.3 volt position, and then you can move it into the ground position. It's not quite as good as using a potentiometer to change the voltages, but at least you'll get to see 3 different values. So going back to the IDE, when we left off, we had a pin in the COM port that was floating all over the place, and I'm going to do the budget circuit first, and I'm literally going to just stick the wire into the ground, connecting it to the A5 pin. There we go, and as soon as I connect it, the value goes to 0. If I move it into the next slot and drop it into the 5 volts, there you go, 1023. Now if you'll notice those numbers there, those were just as I was poking the wire in, and it was sort of half getting there. So once it's in 1023, maximum of 5 volts, I'll then just move it up into the 3.3 volt position, and there you go, you've got a value that's sort of 682, 683. It's sort of partially between the 1024 and the 1023 and the 0 value, probably about 2/3 up. That's about 3.3 volts compared to 5 volts. So that gives you a quick example of analog read. I've now connected up the potentiometer, and I'm just going to slowly turn it, and as I start to turn it, you can see again the values are slowly increasing until eventually I get to the other end and it stops at 1023. Then I can turn it back down. So basically you're seeing, hang on, I've knocked the wire. There we go. So there we go, going from the low value up to the high value and back down again. So now we're going to mod our sketch, and this time I've added a couple of extras. We've got a float, a variable called a float. If you don't know how a float works, it's a variable with a decimal point. If you go to lesson 8 on the Digital Town website, example 4, there is a lesson on how to use a float. So if you don't know, that's the place to go. So the sketch is exactly the same as before. At the beginning we're going to read the analog value. Then what we're going to do is we're going to convert the voltage, the analog value, into the voltage. So what we do is we take the value for read pin and we multiply it by 0.049, because 5 volts, when you divide it by the 1024 steps, means that for each step it's worth 0.049 volts. And then all we're going to do is print out that value. So I've uploaded the sketch, and as you can see at the moment I'm on step 0. As I start to turn the potentiometer, you can see that let's just stop the auto scroll a second. You can see that I'm getting the reading of 361, which is the value of the pin. Multiply that by our value of 0.0049, and that will give me the voltage. Let's put the auto scroll back on. I will keep turning, see the voltage going up until eventually we get to a value of 1023, which is about 5 volts. Again, it's a bit of an interesting one because that 5 volts really depends on the power supply going to my Arduino. So as you can see, it's 0.01 out at the moment. I think I can live with that, and then I'm going to wind it back down, and we'll wind it back down to 0. Now again, if you haven't got a potentiometer, I'm just going to unplug my potentiometer, and so right now I'm attached to nothing. As you can see, the pin is just floating. I'm going to stick that wire from A5 into the ground. There you go, value of 0. Stick it into the 3.3 volt, and there we go. I get an actual reading there of 3.34, 3.35. And then I'm going to stick it in the 5 volts, and again we get that value of 5.01. So I hope that's been useful to you. We've now learned how to read a voltage, how to use analog read. Don't forget that warning, do not exceed your board limits. Now obviously at the moment we've only been able to read the voltages up to the board limits. There are ways to read voltages much higher just using an Arduino, and in the project section of the Digital Town website I will actually be doing an explanation of how to create your own voltmeter and eventually an oscilloscope as well. But I hope you've enjoyed the lesson for now, and if you do, press the like and subscribe. Bye for now.